Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 24. Relative to infinity, calculate the work required to assemble a charged sphere whose radius is r, which contains a total charge q. Initially, we have no radius and no charge. Finally, we have a charged sphere whose radius is r, which contains a total charge q. At any time, assume that we have a charged sphere of radius r prime, which contains a total charge q prime. Assume that we bring a spherical charged shell of thickness dr prime, which contains an infinitesimal charge dq prime. We must do the infinitesimal work dw equals dq prime times ve prime, where ve prime, which is calculated as k times q prime over r prime, is the electric potential on the surface of the charge of radius r prime. Therefore, we have dw as k times q prime times dq prime over r prime. Now we can integrate both sides. Here, k is constant and it can be taken outside the integral sign. In order to calculate this integral, let's find an expression for dq prime in terms of dr prime. Let the volume charge density of this sphere be ρ equals dq prime over dv prime. Because charge q is uniformly distributed through this sphere, the charge density can be expressed as q over 4 over 3 times pi times r cubed, where the denominator is the volume of the whole sphere. From the first equality, dq prime can be expressed as ρ times dv prime. dv prime can be written as 4 pi times r prime squared dr prime. Since ρ is q over 4 over 3 times pi times r cubed, we have dq prime as q over 4 over 3 times pi times r cubed times 4 pi times r prime squared dr prime. 4 pi's cancel each other, so we obtain the infinitesimal charge dq prime as 3 times q times r prime squared over r cubed times dr prime. Also, we can find an expression for q prime in terms of q and r. Finally, we have the volume 4 over 3 times pi times r cubed and the total charge q. And at any time, we have the volume 4 over 3 times pi times r prime cubed and the charge q prime. As a result, you can easily obtain that q prime is r prime cubed over r cubed times q. Now we can put these expressions into the integral. As you see, the integral is over r prime. Therefore, the integral limits are 0 and capital R. If we continue, we obtain 3 times k times q squared over capital R to the 6, and the integral r prime to the 4 dr prime from 0 to capital R, since q and r are constant. The result of the integral is r prime to the 5 over 5, with the integral limits 0 and capital R, which gives capital R to the 5 over 5. R to the 5's cancel each other. As a result, we find the work required to assemble a charged sphere whose radius is r, which contains a total charge q relative to infinity, as 3 over 5 times k times q squared over capital R. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.